All right, let's look at the definition of hyperbolic functions. All right, so hyperbolic sine of x is defined as e to the x minus e to the negative x over 2. All right, so you can think of it as the average between e to the x and the negative e to the negative x. All right, and the hyperbolic cosine of x is defined as e to the x plus. This is the only difference between hyperbolic sine and hyperbolic cosine, e to the negative x over 2. All right. So here's the reason why they're called. They're using a notation that is similar to trig functions, because the rest of the hyperbolic functions are defined exactly the same way as trig functions. So hyperbolic tangent is hyperbolic sine over hyperbolic cosine. Right? Hyperbolic cosecant is a reciprocal of hyperbolic sine. Hyperbolic secant is a reciprocal of hyperbolic cosine, and hyperbolic cotangent is hyperbolic cosine over hyperbolic sine. So you can see that the rest of the hyperbolic functions are defined exactly the same way as trig functions. All right, and it's kind of strange to use exponential functions to define hyperbolic sine and hyperbolic cosine, but let's take a look at their graphs. All right, so I'm going to open up GeoGebra here. All right, so hyperbolic sine looks like this. So y equals hyperbolic sine of x. All right, so this is the graph of hyperbolic sine. So it kind of have the similar characteristic as a sine function. Sine function is an odd function, and hyperbolic sine is an odd function as well. All right, and another way to look at the hyperbolic sine is that hyperbolic sine is simply the average between e to the x, so y equals e to the x. Right, so this is the y to the e to the x, and so y equals a negative e to the negative x. All right, all right. So you can see that there's a purple curve here and the black curve, and the hyperbolic sine is the average between these two curves. All right, and so those are the so this is the hyperbolic sine, and a hyperbolic cosine looks like this: y equals hyperbolic cosine of x. Right, so it looks almost like a parabola. Right, so this one is sum between these two functions. Y equals e to the maybe I'll put that. Let's see. So e to the um, e to the x here, and then y equals, oops, right, so here's y equals e to the negative x, right? All right, then, oh, actually, I forgot to divide by 2, so hold on. All right, so I can change that to divide by 2 there, and this one, and gonna put divide by 2. All right. All right, so those are the two graphs. All right, you can think of hyperbolic cosine as the sum between e to the x over 2, which is this exponential function in green, and e to the negative x over 2, which is the red. And if you add them up, you're going to get the hyperbolic cosine. All right, and then if you look at the hyperbolic tangent, this is what it looks like. Y equals hyperbolic tangent of x, right? So it looks like that, and it almost like looks like the graph of arctangent, but since hyperbolic sine is an odd function, and a hyperbolic cosine, you can see that it's symmetric about the y-axis, so it's an even function. So the hyperbolic tangent is the quotient between these two. It's also odd function, so you can see that there's a symmetry about the origin. All right, so this is the graph of arctangent. All right, that's it. I hope that this was clear.